So I'm going to model a mechanism for the generation of cissoid of 4th degree, the theory of which was examined by Steiner. There it is there. It's a moderately complicated little mechanism, and however, we'll be using GXWeb to see us through the complexity. So for this mechanism, we need a couple of points on the axis and a distance r away from the y-axis. So I made that a, I made that r. And make this one r. And we need a further point, distance a from the axis. And now we're going to have a little crank coming away from C. And its length is prescribed to be square root of a squared minus r squared. Now we need a couple of lines which pass through points and connect in a particular way. So this line here is going to pass through A. Well, we can't do it in one stop, so we'll do it in two. And then this is going to be a line that goes not to E but through it, but passes through it. So we'll make both of those happen using an incidence constraint. So we'll make point A be incident to line DE, and we'll make E be incident to line BF. Again, use this little bow tie shaped incidence constraint. And then further, we need a right angle constraint here. And the final point here is going to be that point F gets a piece of mechanism attached to it, whereby the line DF stays perpendicular to the x-axis there. And so there's my mechanism. Point F goes wandering a long way away. We'll drive it with this angle, this little crank here, angle theta, and point F is what's going to trace out our curve. So there we see our curve. We can look at how it changes as A varies, for example. And we can look at its equation. And there we were promised a 4th order cissoid, and sure enough, it is a 4th order curve.